Good day. This is to give you a summary of Module 3, which will guide you to answer the given exercises. In the next 2 weeks, you will be able to demonstrate understanding of the quantum mechanical description of an atom, its electron structure, and bond formation. In here, you will encounter the quantum numbers, orbital diagram, you will know the octet rule, and relate the importance of having your own identity to relating with other people. At the end of this module, you are expected to create an element artwork that will represent you and how you interact with your friends. In this, you are given directions and the rubrics on how you will be graded in this culminating activity. Exercises 1, please complete me. This is a review of what you know about atom. Its element symbol, atomic number, mass number, number of electrons, number of protons, and number of neutrons. These readings is about John Dalton's atomic theory, a much clearer description of atom as an important factor in explaining the properties of matter, and the laws that supported, which are Antoine Lavoisier's law of conservation of mass and law of definite proportion of Joseph Louis Krauss. As scientists studied, they have discovered many subatomic particles, but only three are important to understand the chemical view of matter. These are protons, neutrons, and electrons. As scientists continue to search for answers on how to represent atom, different models emerged until Niels Bohr had proposed an atom model of hydrogen. He proposed the single electron of hydrogen atom could occupy only certain energy levels. He referred to these energy levels as orbits and represented the energy difference between any two adjacent orbits as a single quantum energy. And to better explain it, I will give you an example which will also be your guide to answer the rest of the exercises given.
As Bohr model talked about energy level, it failed to consider that electron particles also have wave characteristics, which gave rise to another scientist, Erwin Schrödinger. He formulated an equation that describes the behavior and energies of submicroscopic particles in general. These energy states and wave functions are characterized by a set of quantum numbers. First quantum number is the principal quantum number, which is represented by n. This quantum number describes the energy level of each electron. These are 1, 2, 2, and 3. For example, this electron describes a principal quantum number of 1. And this electron describes a principal quantum number of 3. Next, angular momentum quantum number. This describes the shape of the region where you can find the electron. This has 4 regions: S, P, D, and F. S describes that the electrons can be found is spherically symmetrical to the nucleus. This is how it looks like. P has 3 regions, which can either be, this is the nucleus, X region, Y region, or Z region. While D and F are complicated shapes. For D is a combination of P and S, while F is a combination of D, P, and S. Angular momentum can be represented as L. For magnetic quantum number, the value of this depends on the value of angular momentum quantum number. Its value is from negative L to positive L. And for electron spin quantum number, this is based on Pauli's exclusion principle. For example, for magnesium, we have 12 electrons. These squares represents the orbitals. These orbital will hold a maximum of 2 electrons. First, we fill up with positive spin. Until we reach the 12 electron. This represents negative spin, downward. First orbital, we have 2 electrons, 1, 2. Second orbital, which is 1, 2. For the third orbital, we have 6 electrons, 1, 2, 3, 4, 5, 6. And for the last orbital, 2 electrons, 1, 2. A total of 12 electrons. This will prepare you to describe how elements interact with each other. Thank you.